IGCSE Computer Science, Syllabus Statement 1.1.1b, convert positive decimal integers into binary and vice versa. So, what we covered in the last video is what binary was, basically, and a bit of how it's used, although not that much. So this video will teach you how to convert decimal integers into binary and vice versa. So this is more math than theory, so just to let you know that. So just a recap of what we did cover in the last video, and don't worry if you haven't seen it, because I'm sure it's quite easy to catch up. As long as you know what binary actually is, then So just a reminder, our number system is decimal, which is base 10. So like a value of decimal would be 36, for example. Computer number system is binary, which is base 2. So a number would be something like this. And in decimal, since it's base 10, only 10 possible digits exist, which are the numbers 0 to 9. And for binary, it's only 2, which are 0 and 1. So just another recap of what we got to. So each column here would represent a decimal digit. So in this case, say 3, 6. 3 would be here, 6 would be here, and would be 36, and you'll see why in the next slide. But in binary, it's pretty much the same principle. So you could put this number into here, and So yeah, let's get to that. So to better understand this, let's take the number 362. We plug it into this table here. So 362. So we get 3 times 100 plus 6 times 10 plus 2 times 1. So it would be 300 plus 60 plus 2, which would give you 362. So for binary, let's take this number here, for example. We have 1 under 8 and 1 under 4. So it would be 8 times 1 plus 4 times 1, which would give you 8 plus 4, which would give you 12. So that number here, the binary number, would be 12 in decimal. So let's try converting 36 into binary. So we get our table here, and this is one of two methods that I'm going to be showing you in this video. So first we check the number 36 against the leftmost number here. So 128 is higher than 36, so 0 would go under 128. Same with 64. So 64 is higher than 36, so 0 would go under 64. 32 is less than 36, so 1 would go under 32. And 36 minus 32 gives us 4, so now our number is 4. So technically, 36 has been used up by the 32, and then we have a remainder of 4. So we use the 4 to calculate, to check the next set. So 16 is higher than 4, so 0 would go under 16. Same with 8, 0 would go under 8. Now 4 equals 4, so 1 would go under 4. 4 minus 4 is 0. We put a 1 under the 4. But then 0 is less than 2 and 1, so zeros would go under them. So our binary number would be 0, 0, 1, 0, 0, 1, 0, 0. And just like decimal, the zeros in front of the first 1 can be ignored. So these can be ignored, and the number can be read as 1, 0, 0, 1, 0, 0. So let's try the second method, so using the same number to prove that it works. So this is the division by 2 method, so we get the remainder. Now we know that with the number 2, the remainder can only be 0 and 1. So let's do this. So 36 divided by 2 would give us 18 with a remainder of 0. 18 divided by 2 would give us 9 with a remainder of 0. 9 divided by 2 would give us 4, remainder 1. So 4 divided by 2 would give us 2, remainder 0. And 2 divided by 2 would give us 1, remainder 0. And 1 divided by 2 would finally give us 0, remainder 1. So what do we do with this? Well, you'll notice the remainders, as I said, can only be 0 and 1. So there's our binary value. We read it from bottom to top to get 1, 0, 0, 1, 0, 0. And if you want to, you can put zeros here. But that just proves that this method works as well. And you can choose between what method to use. They're both good. So let's try converting binary into decimal. So take this number here, for example. What you do is set out your sort of binary table here and plug the numbers in. So what you do is, well, you do the same thing introduced to you in the beginning of this video. So it would be 128 times 1 plus 64 times 1 and so on, which would give you 202. It's the same thing with this. Plug in the values, find the parts which only have a 1 below them, which are these. 32 times 1 plus 8 times 1 plus 2 times 1 gives you 42. So what about if all the ones are filled and we want to represent a higher number? Because this would be 255. So what about something like 256? Well, remember that for base 2, it's 2 to the power of n, which means that we don't have to go up to only 2 to the power of 7. It can keep going. So 2 to the power of 8 would be 256. So we'd look at this number here, and 256 would then be a 1 put under it, and the zeros are the rest. And you can represent higher numbers than only 255. So if you want to represent, say, 1,000, then you could keep adding to the left hand side 2 to the power of n, and that's it.